All right. So yesterday we started discussing the LaTeX templates for thesis documentation, and we started off with familiarizing ourselves with the various folders that make up the entire thesis structure, and then we went ahead to explore them to see what we had in there. I think we ended the day. Okay. So today we are going to continue with creating, inserting, and editing chapters. So like we said from yesterday, the main chapters of the thesis are separated from the formatting files, which is the class and the style files. And then it's also separated from the front matter, the back matter. Now we want to go through how we could create, insert, and edit these chapters. So the chapters of the thesis contain the main content of the work that you have done. Usually, we have about 5 chapters, our traditional thesis system, but for some, it differs from department to department. For some department, they would want you to have a whole section on discussions alone. So some you do 6, some you do 7, but the standard one is at least 5 chapters. For each of the chapters, you create a file for it. So you have, and each file would end with a .text. So in your chapters folder, you can have introduction.tex, literature review.tex, methodology results, and conclusion. Now, when you are able to define each of these chapters, create a file for each of these factors, each of these chapters, you go back to insert it into your main thesis file, the main thesis the main.tex file. And with the chapters, you would also have to initiate. We mentioned that for the front matter, we work with the Roman numbers. Now, when we start with the main chapters, it starts counting from the Arabic numbers. So you would have to indicate. And I remember yesterday, Mr. Albert taught us how to initiate the chapter numbers. So when you start, you'd have to initiate it. So when you create a chapter file, so yesterday I showed us how we could create the file in the folder. Quickly, for us to refresh, as a refresher, I want to go back to the file for us to take a look at it. Okay. So from yesterday, I mentioned that if you didn't even have the chapters there, you could go to the folder, new folder, create a new folder called chapters. So let's say chapters 2, because I already have a chapter over there. Now, when you create your chapters, I created it inside the chapter 2 file. Let me delete it and then do it again so that, okay. So let me stand anywhere here, come to a file, the new folder, and create a new folder. This is it's just a refresher for those who probably were not here yesterday. So you create your chapter folder. So in your chapter folder, you can create your introduction.tex, your literature review, your methodology, and what have you. So this is the new file. And we come here, we say introduction.tex. Now we see that the file has been created under the chapter folder. So you can keep on and create at least your 5 folders to include your literature review, your methodology results, conclusions. So working with what we already had, the template we already had, we see introduction, literature review, methodology, results, discussion, and so forth. All right. So once you have created the file, the first thing you do is to call your chapter. So you'll use the chapter function, so chapter introduction. The chapter that you would want to discuss in that file is the introduction. So I realized that for the template we are working with, when you go to the main file, so let's go to the main file. Let me show you something. When you go to the main file, you see that they defined for each of the chapters, they defined the chapter introduction and then they put it in. So when you create your file, you don't need to do another chapter introduction again. That is their template. So in their templates, when you go through it, you realize that when you pick something like their introduction, for example, I have edited it, but you don't have it that way. You will see that it starts off with /section. I edited this one. So you see chapter here, but in the folder that was served you yesterday, you wouldn't see /chapter in there. You would see it on the main file. But then I'm saying that most of the time, I wouldn't say the standard practice, but most of the time, that is what you do inside the introduction file. You specify that that chapter is your introduction. Now you realize that in the abstract and in the front matter, we put an asterisk on the chapter because we didn't want to number the chapters. Now for introduction, for the main chapters, we would want to number them. So we'd have introduction, background, etc. So in doing that, we don't have to put the asterisk sign on the chapter. Then when you finish, you start defining your sections, your subsections. I think it goes up to subsections, and then it does the numbering properly for you. So you don't have to worry about how it will do the numbering for you. But once you do it, so let's say chapter is 0.1, your section, if background is a main section under the chapter, it will do 1.1 for you. If you have another subsection under the background, like the motivation, it can go 1.1.2, sorry, 1.1.1 for you. So it does the numbering for you. And then the subsections and the subsections and the sections are created for you automatically. All right, so once you are done putting in your content and creating your files and everything, how do we insert it in the main chapters? So I mentioned this yesterday. The function that we use to call these chapters is the input. So you do your /input. The folder that is housing your introduction, literature, etc., is your chapters folder. So you would have to make sure that whatever you are calling is in there as chapters. If you did it chapter 1, you have to make sure that it is there as chapter 1. So in here we have chapters. So chapters / the first one is your introduction, your literature review, in that order. If you don't arrange it well properly, let's say you do input chapters methodology will definitely appear before the introduction, which is not right. So all the time, you have to make sure that on your main file, it is like that. So when we go back to our main file, our main.txt file, okay, so over here, we see input chapters, introduction. We have input chapters in literature, methodology, results, discussions, and conclusions. So all of them is beautifully arranged over there in the template. Okay. So here, the order is very important because it determines the order of the final thesis. And then the chapter numbering is also handled automatically. So remember that before you start bringing in your main chapters, if you have not specified it in the .style.sty files, you have to indicate it here that your page numbering should be Arabic because you are swapping over with the Roman numerals you started off with for the front matter. Okay, so I want us to try with our hands on our third task. Our third task, I want us to create a dummy chapter. So you can have a special chapter, you can have your introduction methodology, and then at least add one section, subsection, add a few dummy sentences, and then you insert it back into your main file. So I want us to do that, try our hands on it. So we just created our chapter 2.2, chapter 222. It's a new file we just created. And then we created introduction. Because we already have an introduction, then let's rename it as introduction 222. All right. So when we come in here, we want to start off with chapter introduction. All right. Chapter introduction. So this is our first definition. It's very important. We want the introduction to be numbered. So we wouldn't put the asterisk sign on it. Now, if we have anything, we start off with our section. So our section is, let's say, background. Okay. So with the background, what do we want to write? Let's say we have a dummy test. We want to use this dummy test. The lips is a dummy test. You can put anything. You can copy a test from wherever you are to this place, but we want to insert a dummy test. And then now we don't have this introduction 22222. We don't have it in the folder. So what we are going to do is that we are going to the main file, because now as you have created it like that, so we are going to comment this one out so that we can replace it. So now let's do /input, then the chapter we created was chapter 222. All right, and then we have introduction like this. So let's run that and then see what we have. For clarity's sake, maybe we should add for our chapter for this, let's add introduction 55555 like that, so that when it appears, we would know what we are doing. Okay, so you do Control S and let's see what happens for us. So it's still compiling. Okay, good. Now we have blah blah. So introduction. So you realize that I had replaced the introduction chapter with the one I just created. So now I have introduction 555. And the first section is section 1.1, which is the background. And I asked it to give us a dummy test. So this is the dummy test we have. All right. So from here, you can insert your subsections. You can insert your subsection. And the subsection is, let's say, motivation. Now, with your motivation, we are still inserting a dummy test, but we are using just 2 sentences, I think. So we can run this. So for a number of the templates I have worked with, usually when you run it on the, okay, so most of the templates I have worked with, when you are anywhere on any file except the main file, when you compile, it gives you an error. But this particular one does it even without being on the main file. So maybe in the near future, if you pick a file, you edit it, and then you run and it gives you an error, it doesn't mean you are wrong. I think one of the first things you should do as you're troubleshooting is to go back to the main .tex file and then run it from there. So we realized that our motivation to has now come. It's well numbered as .111. All right. I know Albert took you through the indentation. So you see that we have some space here showing some paragraphs. Now, if you don't want that, you do the slash indent, no indents, and then it can correct the indentations for you. Okay. As much as possible, don't call any package in this file. All that you need there is your chapter and your sections, and then so try and push that file in your
Right.
Great, great.
Okay.
All right. So we have one success. I'm sure we are all trying. So let's continue. Now let's look at inserting equations. I mean, before I moved full LaTeX so many years ago, maybe not so many years ago, but some years ago, one of the things I really loved about it was the ease with typing mathematical equations, because typing mathematics in Word was so difficult for me. Like trying to make things out was really difficult, but in LaTeX, it's so easy comparatively. Now, LaTeX is very good and a very powerful when writing mathematics equations. And with LaTeX, you can write your equations inline within a text. So let's say you are saying um, y equal to ms plus c is an equation of a line. It is a sentence, so you can write it within it. Another thing is that you can also write your equations outside of your text and display it and even number the equations. And with LaTeX, your equation numbering and your referencing are always handled automatically. So for example, the inline equation, like I was saying, you are writing a piece of sentence, a mathematical statement, and you get to a point where you have an equation in the statement. You can do your You just have to define the environment with the $2 signs like you are seeing here. Now, when you do these $2 signs with your y equal to ms plus c, it's going to appear in the sentence. It's an inline equation. Now, if you would want to separate your equation from the text and even number the equation, we use an environment, the equation environment, where you are able to define your equation in there. Now, if you don't want your equation to be numbered, you bring an asterisk sign on top of the begin. If you want it to be numbered, for example, you have about 10 equations and you are trying to do a presentation, or even in your thesis, usually the reviewers have to follow. So let's say you are working on some differential equation models. When you take the first one, you have to number it and let us know what the first model is, what the second model is doing until probably you get to your solution. So once you are able to number it from equation 1 to equation 30, everybody picks it and they are able to follow. So for you to do that, you are able to use the equation environment to do that. Usually, when you are done with your equations, you would want to label them. Labeling them is so important. I know Mr. Albert mentioned it yesterday, but labeling your equations is so important that when you write your equations, you would always want to reference it. So when you label it, for example, what we've given it a label as equation semicolon model. You can name it, you can give it any name at all. Let's say if I was doing wave equation, I could label it wave equation. Now, when I come into the referencing, like Mr. Albert taught you, in the sentence, you want to make reference to that equation that you have just put out there. Most of the time, you number your equation. So you just want to tell us that, so in equation 1, A, B, C, D is So in equation 1, we are using the heat model to the heat model to do A, B, C, D. That you are referencing the equation in the sentence and we are able to follow. So all the time, you have to make sure that you label them and you reference them properly. Now, quickly, we are going to take our task 4. In LaTeX, I realized that Overleaf, when I was exploring them, your option to just go and pick the symbols, it's for the premium. I may be wrong, but I stand to be corrected. But when you are using LaTeX on your local machine, you have free access to all the symbols. But now one of the things that can really help you is that this, is just a capital Y. So the first thing, I'm asking you to write this equation in LaTeX. Now, this is the format you are going to follow. You are going to first write your begin equation, end equation, and then you are going to define this function. Capital Y is capital Y underscore your small I equals to your alpha plus your beta x1 plus your epsilon I. So if you know the names, sometimes you can just start typing them and then automatically it will come up. But then if you have the premium version of Overleaf, you can just go and pick the symbols. If you are using your local machine, you can always, on your left-hand side somewhere, you have the list of symbols there. That is, if you install LaTeX locally on your computer, you should have all the symbols sitting somewhere. Then when you finish, I'll need you to insert it as a numbered equation. Don't just write as an equation and leave it blank. I need it to be numbered, and I need you to add labels to it, and I need you to find any sentence at all and reference it. So we want to go back there and then go and do it. Okay, so let's go into we can create another section here for methodology, but we already have methodology in our chapters, so let's just make good use of that. So we come to our methods. Now, with the methods, okay, we want to do the equation task that we have. So we said we were going to, so the first thing you do, you define so let me do this to just give it some clarity. What we are going to do, we are going to do task 4 over here. All right. So with task 4, we said we want to insert an equation. Okay. We want to insert an equation. So the first thing we do begin equation. Sorry. Okay. Begin equation. Okay. And then so we've defined the equation environment. Now our equation was capital Y underscore I was equal to some alpha. So you see that the moment I start typing alpha shows up. So alpha. But usually, if you come to over here, insert symbol, but unfortunately, I don't have the premium version, so it's not giving it to me. But if I had the premium versions, you could see that almost all the symbols are defined over here. But these symbols, like I said, on your local machine, if you have installed it, it is free, so you can have access to them. Okay, so alpha plus, alpha plus beta, so slash beta, capital X underscore, capital X underscore 1 underscore I, then plus your epsilon, okay, underscore I. So that was the question. And sometimes, if right now, if you are very familiar with the overleaf and you are not so comfortable with downloading it on your local machine, when you have an equation and you're not so sure about the symbol, you can always check what symbol it is. And then you can take another step of asking how that symbol is written in LaTeX. But most of the time, once you know the symbol, the moment you start typing, it gives you the option to just continue. Now, when you are done, before you end, you would want to label this equation. So label. And then would want to give it any name, maybe regression or regress 1, something like this. So let's run it and see what we have. Okay, so let's push it to methodology. Okay, so let me do this well. I want it to come down, so I would have to break the lines. Great. So over here, we have the task 4. Now for the task 4, we see our, let me expand this a little bit. All right, so with our task 4, we see our yi is equal to a plus beta xi plus the epsilon, and then we are saying that is equation 4. So because I had written it severally in the document, it does the numbering for me like one after the other. So the next equation would assume the next number in that order. All right. So let's say that you didn't want the numbering. You didn't want the numbering. You just want to write the equation without numbering it. That's when you put your asterisk sign on the equation like this. So when you run it, the same thing. Now, when you run it, you realize that your task 4 is not numbered. Please, can you see that? I know my screen is a bit messy, but please, can you see that?
Yes, we can.
Yeah.
Yes,
So the
yes,
task 4 is not numbered. So
yes, we
when you
can see.
don't, yeah, great. When you don't want it numbered, that is how you go about it. Now, yesterday, I think Mr. Albert taught you how to insert or refer to the equation. So I want this to really show as my equation 4. So I'm not going to put an asterisk on it. So let's say I want to say that the equation above, the equation, so instead of saying, so that's one thing that a lot of students do that always make it very difficult for reviewers to appreciate their work. Usually, when you insert your tables and your images and your equations, sometimes these are floats. And then where you probably would want the image or the equation or the algorithm to appear, it may not appear at that exact place. But when they are doing the discussions or they are writing up the results, they will say that from the equation above or from the table above, from the image above, you go there and there is no image above because it couldn't place it there. So the reference is very important. So instead of saying from the equation above, you do from equation, and where is my tilde slash your reference. Then the reference we have there is our no, not this. It's RGL this. Displays A, B, C, D, E, etc., etc., etc. Your test continues. So when you run this, you should, all right. So when you run this, you should have the equation 4 displays A, B, C, D. All right. Sometimes if you don't want it to show as just 4, you just want it to come in a bracket and all that, you are able to put them in a bracket and you are good to go. Okay. So that is the task 4 that we just went through. So inserting images. Yesterday, Mr. Albert took us through how to insert an image in LaTeX. And all the time, the environment is very important to us. Usually in your thesis documentation, you would want to specify the environment you are working in. And yesterday, he mentioned the figure environment. This, we did it yesterday, so I'm not going to waste time on it at all. So you know the figure you are working with, you know the folder you have kept it in, you define the environment, and then you include your figure and your caption and your label. Sometimes, so most of the image formats that it accepts, it's not just PNG, it can accept a PDF. You can have an image that is a PDF, you put it, it will work. You have a PNG, but there are some other extensions like the GIFF like this. It usually doesn't pick up so easily. So usually you would want to make sure that your images is one of these formats, with one of these format extensions. And I think JPEG also works. But usually when you are defining your image in the environment, you can choose to add the extension to it or not. One very important thing, this thing is very important to me. I think yesterday Mr. Albert mentioned it briefly, but the placement, like I just said with the referencing, people would usually put an image thinking that it has appeared in a certain position. I would reiterate this thing again. And then when they are discussing the image, they go ahead and say the image above and the image below. It is very wrong. And that is one very common thing that LaTeX does. Usually you think that you have placed your image at the top of the page. You finish, you render, sometimes you don't even check the work, then they will submit it. Then when the work comes, the person will be saying something else on a different page. So one of the things that you have to really pay attention to is the placement of your image, the placement of your table, the placement of your algorithms and all that. Now, the placement is very key. When you define your figure environment, you have to be interested to see where the figure appears. So there are common placement options. I remember yesterday someone was asking about how about big H, how about small h and all. So the common placement, we have the H, we have T, we have B, P, and then HTBP. Now H simply means here. When you you define your environment and you include your graphics, when you use H, like this example, when you define the environment and you include H, you are saying that the figure should appear here if it's possible. So if it checks the alignment, you check the space, and then the image can fit there, you are telling LaTeX to put the image there. Now, maybe you don't want it there. You want it on top of that page you are working on. That you use T. That means the image should go to the top of the page. If you use B, that means the image should go to the bottom of the page. And then when you use only P, you are telling it that it should go to a page that has only floats, that has only images or tables. So let's say you have defined one table. So usually sometimes when you are working, you have one page that you are compiling your images there, and then you talk about them somewhere else. So usually when you just use P, LaTeX will go and search for a page that has only floats and put it there. Now, most of the time, the recommended one is the HTBP. It allows for a lot of flexibility. Once you put the HTBP there, It is flexible. It will go and search wherever. If it's possible that you put it here, it will put it there. If you use it at the top, it will go. If there is a good space at the top, it will take it there in that order. So that is why it's very important for you to check the placement, so that if you move on, you don't go and discuss the image in another page, which is not there, or what you were expecting, you are sure that you have achieved it. Now, sometimes you really want the image to sit at a particular place, and then it's not sitting there. In that case, you can use the big H. But then the big H, you always have to use it with a float package. When you call the float package and then you specify big H, it forces the image to appear exactly where you want it to appear. So the disadvantage about it is that whether there is enough space, whether there is enough width, whether there is enough whatever, it doesn't care. It will force it to be there. And sometimes it will distort your alignment and a few other things. So you just have to be careful when you are doing it. Because Mr. Albert taught us how to insert an image from yesterday, I'm not going to do that. The thing I'm very interested in is how to scale your images. So I realized that one of the things that reviewers in general are very particular about is the presentation of figures in manuscripts and in your thesis. Sometimes you can do a very good work, very beautiful graphics, but the way you present them just takes away the beauty of the work. So usually, first of all, when you are generating, whether you are using Python or MATLAB or R or whatever you are doing, make sure that you are generating very beautiful images. When you are done and you are inserting them in LaTeX, sometimes the images appear very, 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 very small. Sometimes it appears very, 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 very big on the page. So we have something we call scaling when it comes to imaging. So usually depending on how it's looking like, if the width is spanning a very longer part of the page, you can adjust the width with text width. If the height is so long, you can adjust it with the height. So instead of just calling include graphics, include graphics, figures/sample image, you have to define the width. You have to define the width of the image. So you can do 0.7, 1.0, 2, depending on the width of the image. You can also adjust the height. If you think the height is too short or the height is too long, you can always adjust it with the height function in there. Then the interesting one to me is the scaling proportionally. So instead of adjusting width, adjusting height, adjusting whatever, you can decide to just scale the image. So let's say that with the scale, the original image is there. Now, if the original image is too big, you want to just tell it that it should scale it down to half the size of the original image. That you can specify scale to be 0.5. If the image is still too big, you are asking it that, given the original image, it should give you only 1/10 of the size of that image, so that you are going to use 0.1. Now, if the original image is very, 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 very small, you can ask it to give you twice, that's double of the size of the original image, or 5 times the size of the original image, so that your scaling will be equal to either 1, 2, or 5 in that order. Then again, you would have to give a caption to the image you have. Sometimes your caption should be a bit informative. Usually, some people will just do a very beautiful image and they will just do relationship between X and Y. No information. We don't know the kind of plots you have created. Sometimes to you is so trivial that, especially when you are writing your paper publications, you think that, oh, this is a box plot. Everybody should know it's a box plot. It would be so amazing for you to know that there are some people who don't know what a box plot is. So they will see the image and they don't even know what you have created. So usually you would want to add a bit more flesh to your caption. Then you label it and you reference it appropriately in the text. All right, so our fifth task, we are going to create an image folder. So either figures, so on the template you already have image folders over there. It exists. If you don't have it already, you can create one. Then look for any image at all. Put it there. So it can be your university image. It can be any image at all. Then you insert it in the methodology file or any file. You can put it in introduction. I mean, images can go anywhere. The results, the introduction, any file. Then see how the image behaves. Is it okay? Is it too small? Is it too large? Is the width too long? Is the height too long? Then you decide to choose any of them. So you can decide to scale the image and then add your caption and your labels, and then we are good to go. All right, so let's go back and let's try this. So I have an image folder already. I've named it figures. In the figures, I have images on the DNA. And yes, so I want us to work with this. So you can also load your image, any image of your choice. I want you to do that. Okay. So I'm going to choose, let me say, the literature because it has scanty information. So let's say over here, we want to discuss the DNA. So we want to insert something like the DNA in here. So we do begin figure. So the beautiful thing about Overleaf, you wouldn't get this in your normal, how do we call it? Your normal, most of the time, your normal local LaTeX that you have sitting on your computer. You will not have it this way. Usually you have to type everything one after the other. But on Overleaf, once you define the environment, it gives you all of this. So all that you have to do is to tell us the image you'd want. So I want to use a DNA image. Then you run it. Okay, you compile it. So already what LaTeX was given to me, so this is what I have. All right, this is what I have. Now, if you look at it very well, okay, let me expand this a little bit. Okay, so, okay. So one thing that I would want you to take note is that you realize that automatically the caption came on top of the image. Ideally, most of the time, it's not like that. The normal LaTeX template, the caption for especially figures, tables usually appear at the top, but figures would always come. The default is that it would appear at the bottom. Now, in this .tex file, one of their global rules was that the caption should appear at the top. So because of our time, I will not go in there to show you. But when you take your time and go into the .txt file, you will see that they have defined that the caption should appear at the top. So if you comment that thing out, it would automatically come down. Okay, so now we have this image. And, okay, so we have this image. Now let's say we don't want to adjust the width. These people gave us the width. We are saying we would want to scale this image. We want to scale this image. this image is probably too big for us, depending on what we are doing. So we want half of this image. So you can come and scale it 0.5 like this. And then you see that the image has shrunk. Now it's much, much smaller. So this is half of the original image. Now, we initially we said the original image was too small for us. We want to scale it. We want to have double of that image, double of the size of the image. So we do scale is equal to 2, and then we run it. And this is what we have. Now, when we want 3 times the size of the image, this is what we have. All right. When we need 5 times of the size of the image. This is what we have. So most of the time, unless the height of the table or the width is too big for me, I prefer to use the scale to regulate the size of the image. Okay, so let me just use 1 and then we continue. So this is 5 times. It's so big, it's taking so much space, you don't need that. So now let's scale it back to 1 and then we see what we have. Okay. So this is what we have for 1. So that is how you are able to change the size, scale the size of your image. Yesterday, once again, Mr. Albert took you through inserting tables. He spoke about the table environment, the tabular environment, and he really stressed on the fact that the tabular environment is used to create the content. And usually the table environment is for the aesthetics. It helps you it puts the table as a float. You're able to give it a caption, you're able to label it, etc. So usually when you just use the tabular environment without the table, you are just creating the content of the table. Okay, so when you have it, this is the basic structure of a table. You did this yesterday, so I'm not going to waste time here. You discuss the alignment. So he mentioned to you that when you define your tabular, you have to define the alignment of the columns, the appearance of the column. So if you want the text to be left aligned, center aligned, right aligned, you use this. So this is it. So when you see L, so now that you've been exposed to LaTeX, every time that you want a piece of code, you go online to go and search for help and you get one. You should try and understand what they are writing before you just replicate it. So when you see them using LLL, you know that they want the text to be text aligned. If you see CCC, you know that they are doing center aligned or the right aligned. Then the vertical bars, you knew what he mentioned it to be and the referencing and all. So as for this, you did it yesterday, so we are not going to waste time on it, but we would need this table very soon. Now, what is of interest to me over here is handling long and multi-page tables. Now, what Mr. Albert taught us yesterday, you use it in scenarios where we have a very simple table, a very short table that can fit a page. Now, there are instances where you have a very long table. So the function table does not automatically break across the pages. But then in our thesis write-up, we do have a lot of very large tables. It's very common in our thesis, especially when we have a survey data or we have a regression table, and especially in our appendix, sometimes when we have very long stuff. Let's say you do enrichment analysis after you've done your gene expression analysis, and then you have a very long table discussing your molecular pathways and all that. You can't keep all that on one page. So you need them to be in a long table, but that will span across the pages. So you start a table on one page. Because it's so long, it can span across 4 or 5 pages. And LaTeX has a special tool for handling that. So that tables can span across multiple pages, column can span across multiple columns as well as rows. So for long tables, we use the long table environment. The long table environment. The long table environment extend over the pages automatically. So it's just break across the pages. The headers and the captions repeat on each of the pages so that we are able to follow. So let's say you have one thing, it's so long, so you put it on the long table environment. Now, when it breaks across the pages, for every page, it will repeat the caption. If there are headers, it will repeat the headers on each of the pages. So you don't have to do that automatically. One of the key differences between the table and the long table environment is that the table uses a single page. We just have a single page. When you have a table that can fit on a single page, we use the table environment. But then when we have a very long table, we use if we have a very long table that will span multiple pages, we use the long table. So over here, this is an example. We have, let's say we have this, and then we'd have to define some variables here and there. The first thing you do, you look for the environment, and then it's a long table environment. Then over here, we put the caption at it. Mostly the table, the caption appears at the top. Then you define your variables like that. So then after that, after you define the variables, you put in your H lines and everything, you end your long table. So when do you use them? When you know your tables can't fit one page, you use them. When you have very large descriptive tables, you use them. When you have regression outputs, when you have tables in appendix, you use them. All right. So the table one we created, if you have any table at all, what I want you to do is to just convert that existing table into a long table, a very long table. So you can just copy and paste it multiple times. But I need you to define the environment, long table, so that it can span across the pages. So let's look at how we can do that. Okay. All right. So the first thing we do here is to define the environment. And the environment is the long table environment. And then we have 1, 2, 3, 4, 5 columns. We have 5 columns. Now, when you start, so over here, because of how long it is, I just didn't want to start it. So when you do begin long table, like this, you define your environment. So once you define your environment, you specify the caption, the label of the table, then you can start. You specify your top rule, and then you define all the variables that are supposed to be there. So here we have ID, we have feature, we have accuracy, precision, and recall. I'm going to make this code available after the class. So I just need you to follow through, and then you will see how it would appear. Now, if you want this header to be repeated on the multiple pages, you keep writing that. So you have your top rule over there. Then now you come to the main table from 1 to about 50. We are looking at that was the ID. We are looking at different features, their accuracy, their precision, and what have you. So obviously this cannot fit on one page. So let me delete this, and then let's run this. And let's see what we have. Okay, so from here, we start with our longer table. So we defined the caption, which was the figure accuracy table, then the ID, the various in there. Over here, we didn't use the H lines, we didn't use the, so yesterday, Mr. Albert taught you that the horizontal bars that were there were used to divide the table, like, how do we call it? Create the cells in the table. But here we didn't do them. We wanted a free table, so we didn't bring all those pipes. Yeah, that's the word. We didn't bring the pipes. So we didn't have them. We don't have it looking like this. Then we also showed our top row, our mid row. It's just like the horizontal space. So we didn't see H space here, but then we used the top row and then the mid row and all that. So we see that. Then also we wanted to have footers. So we specified the footers in here, the footer for the immediate page. We said table continues on the next page, just so that when someone is reading, they would know that this is not the end of the table. The table would continue. So this is the table. Now it continues to the next page in this order. All right. So please, I'm going to make that code available to everyone so that you can try your hands on it. If you have a very long table, you know how to work around it. If you need help, you can always reach out or you can always find help online. All right. The next thing is spanning columns and rows. So sometimes you are working on something where you want to put two rows together to make a statement. You want to put two columns together to make a statement. We have what we call the multi-column and the multi-row when you are working with a table. Now with the multi-column, it helps you to put two columns together, and then with the multi-rows, it helps you to put two rows together. With the multi-column, all the time, the first thing you specify is the number of rows. So you call the function your multi-columns, then the first thing is the number of rows. So with this specific code, we are looking at the number of rows is 3. You want to combine 3 rows together. The second one is usually the alignment. And then the third one is the content. So when you see these things, we are going to take examples of them and you will see how it behaves. In the same way, if you want to use the multi-rows, for all of them, you would have to call in the package. So for multi-rows, where you would want to put multiple rows together, we use the package called multi-rows. Now, when you are starting, you still start it within the tabular environment and you can call your table for the aesthetics that comes with it. Now, for the multi-rows, the first one is the number of rows, and the second is the width of the table, and the third is the content. So over here, we wanted to combine the gender, male and female, as one column, and then whether people were married or not married as another column. So that's the example. So this is the output. This is how it looks like. For the gender, we just wanted to compile the male and female into one column, into one row, and the married into another row. So all the time, you use the multi-column to do that. Then for the multi-column, like I said, the number of rows, the alignment, and then the model. So once you do that, you are going to have something like this. So this is just a raw picture of how it looks like. But if you want to put this in a sophisticated table, you can always have your way around it. You just have to sit down and then spend some time to figure it out. So this is how you go about merging rows, merging columns, etc. All right. So because we have, I presume that we had done so much on the tables yesterday, I wanted to give you this extra information about the long tables, spanning of rows and columns and all that. So now let's look at inserting algorithm. I know most of you probably do a lot more in computing, so I wouldn't waste my time defining what an algorithm is. But the important keyword I want to mention here is a step-by-step procedure. An algorithm is a step-by-step procedure that is used to solve a particular problem. So in LaTeX, the algorithms are treated as floats, just like the way figures and tables are treated. It has automatic numbering, it can be referenced, it can be captioned, and what have you. So for algorithms, there are three things that we can talk about. The first one is the algorithm itself. The second one is the algorithmic, sorry. And the third one is the alg pseudocode. Now, the algorithm provides the floating environment, just like the algorithm over here serves like the table. You see the difference between the table and the tabular. The tabular creates the content. It gives us the content of the table. And the table itself, the table environment, gives it the aesthetics. It makes it the float where we can position it somewhere, give it a caption, give it blah, blah, blah. So over here, the algorithm itself, the algorithm environment provides the floating environment for the algorithm where we can specify the caption, the labels, and what have you. And the algorithmic and then the AL pseudocode, they provide the content. So the algorithmic and the AL pseudocode, they almost do the same thing. The only difference is that the AL pseudocode is an updated version of the algorithmic. So usually they will say the algorithmic is a bit older. Its newer version is the AL pseudocode. But however you use them, you should have results. They would work. So if you don't have ALG pseudocode, you can always use the algorithmic to create the content of the code and then use the algorithm as its floating environment for you to position and caption and etc. So for example, if we want to write an algorithm to clean a certain data, what is the step-by-step approach that we use to do that? The first thing we do, we define or we declare our environment, the algorithm environment. The algorithm environment is what gives the algorithm, put it in a floating state where we can give it a caption and a label, etc. Then when we want to create the algorithm itself, we use the algorithmic or the alg pseudocode to do it. So once we define it, we load the data. So the step by step, we now define it over here. Then we end both. Okay. So this is a very simple example. We want to create this algorithm. It's a cleaning procedure. We want to create it. Once we go through it, the step-by-step approach like we have, this is what comes. This is what we see. We see algorithm 1. Automatically, it numbers it for us. The name, the caption we gave to it was data cleaning procedure. So algorithm 1. We didn't specify anywhere that this was algorithm 1. But when we run it, this is the first algorithm that we have run. So it gives us algorithm 1, and the name is the data cleaning procedure. And it gives us the step-by-step approach in cleaning the data. All right. So if you'd want to reference the algorithm, just like the way we have reference tables, figures, etc., we can reference it the same way, because over here we were able to give it a label. And we are able to give it a label because the algorithm environment allows us to give it a label. Once you have a label, you can always reference it. Okay. So the algorithm numbers, if you're able to give it a caption and you're able to give it a label. You don't have to go type in the algorithm numbers manually. And you are saying that from algorithm 1. You don't have to do that. Once you put in the reference, it will automatically call it out for you. So this is a trial. This is our 8th task for this work. We would want to write this algorithm 2, step by step. But if I want us to use the algorithm and algorithmic, I always struggle with this word. But then you can also try your hands on the OWL pseudocode, and then you see what you have. You give it a label, you give it a reference and all that. So we will go back. Okay, so good. I think I have a snippet of the code over here. So I will just take us through quickly and then we continue. So when you want to insert the algorithm that I just showed, we specify the environment, begin algorithm, end algorithm. That gives us the floating stuff. We specify our caption and our table, and then we go ahead and then define the environment itself. Then we start our step-by-step approach. So when we run this, we should have, so I'm going to make the code available. After the class, you can take your time and explore it and then have it. So once we run the algorithm, over here is the first algorithm we are running. So our step-by-step, we required something, a data set, we ensure something, we go the step-by-step approach, and then we return the main thing that we are looking out for. Okay. I know you understand these things better because you are computer scientists. Most of you are computer scientists. Okay. Now, the last thing before Prof comes in, references in LaTeX. Now, references is a big part of your thesis. In fact, not just your thesis, your publications, your presentations. Today, in our department, I am in the maths department here in Keio University. In the department, students came to present their thesis, postgraduate students. And some of them would come and then their references are numbered. For a presentation, you can't number your references. How do I know that one is referring to Kojo et al. Or Apathy et al.? It's not done. So references is a big part of the work. I have seen a number of people get their papers rejected because of references. Sometimes just referencing style, they reject a paper. So references is a very, very important part of the work. And LaTeX handles it perfectly. It handles references automatically, gives it a good in-text references and all that. Typing your references manually is really discouraged. If I had a better word, I would have put it there. Never type your references. That you go there, you go and pick your, you see the paper, you go and pick the reference, you start typing it one. It's not done. Please don't do that. Now you are learning LaTeX. You should be very comfortable working on your references in LaTeX. Now, LaTeX has 2 common systems to handle your references. There is the BibTeX and the BibLaTeX. The BibTeX is relatively older, but I still personally use the BibTeX and the NatBib almost all the time. The BibLaTeX is much current and it gives you a bit more flexibility, and it's actually it's recommended for you to use. Now, why the BibTeX and the LaTeX? Like I said, they format the references automatically according to the style you want. If you want alter year, it's very easy for you to just specify it and it will show as alter year. If you want it to come as numbers, it's there. If you want the reference page to show as APA-like, you just have to specify it. It's that flexible. And the Babe LaTeX or the Babe Tech actually ensures consistency. It's very consistent. I think last semester or last 2 semesters, I was reviewing someone's work from AIMS. It was an external thesis that came. On some of the pages, the person has author year. On some of the pages, the person has numbers. So just that thing alone, I was like, what is this person doing? You can't do this. If it's author year, you keep it consistent across board. If it is numbers you are doing, you keep it consistent across board. So usually when you are using LaTeX, once you define a certain style for it, if it's author year, if it is numbers, it is consistent. It doesn't change along the way. And then when you use the BibTeX or the Babe LaTeX, it makes citations very easy. Very, very, very easy, and able to manage your references easily. And maybe sometimes you don't want a certain style, you want to switch between the styles. You do that easily without any challenges. So in LaTeX, if you want to do your references, the very, very important file you have to create is the bib file, the .bib file. The .bib file is very important. That is where all your references are stored. So when we come into our back to our template, you see bibliography. You see that it has already created a reference bib file for you. Now, even if you didn't have this reference, you can create it yourself. By this time, I'm expecting everyone on this call to be able to create their own folder and specific files in there. Now, if you are creating for references purposes and not for writing purposes, you don't have to make the extension .tex. The moment you do a .tex, we are expecting you to write, insert, etc. Now, when we are talking about references, you have to create a .bib file. So whatever you write is .bib. Now, LaTeX can identify it as a reference file when you put it in your main text file. So the first thing you do is to create your bib file. And then when you create your bib file, each reference that you put there would have a citation key. We are going to see that very soon. And with the bib file, once you create it, you can reuse it across different documents. So the structure of it, you have references.bib. You can name it anyhow you are comfortable with. My reference.bib, my whatever.bib. The most important thing there you have to take note is that the extension must be .bib and not .tex. Okay. Now in LaTeX, we can cite all sorts of things, just like in Word. We can cite an article, we can cite a book, we can cite an in proceedings from a conference, we can cite a thesis, we can cite a report. So based on what you are supposed to cite, you know exactly how to go about it. Because if it's a thesis, you have to specify it's a thesis because it has a structure LaTeX would generate for you. So over here, because we are doing specifically bib file, we are just creating the bib file. Let's see how we do it. The first thing, when you have a paper that you want to cite, you want to read something you want to cite, the first thing you do, you can search for because your interest is to get the bib citation. So the first thing you do is to search for the paper on Google Scholar or any other place that can give you the bib file. You can enter it manually, but you have to be careful about it because sometimes you are not able to do it so well. So let's go back. Let me show you something. Over here, when you go into a reference file, this is how it looks like. So like I said, if it was a book, it will start with at book. This is the reference key, the citation key. This first is usually generated. You can generate it yourself. And then what I'm coming to teach you right now in a few minutes, sometimes it comes with its own reference key. So the approach I'm going to show you right now, if it doesn't work, that means that you would have to figure out the authors, type it, the year, type it, the title, the location, the publisher. So if it's a book, this is how it looks. Now, because we are prone to making a lot of mistakes, I don't encourage you coming, picking the paper, picking the author, and writing it one after the other. So one of the important things I need you to do is to follow this cycle. The first one, you search for the paper on Google Scholar. Then you go to cite the paper. You select the BibTeX option. You go and copy the BibTeX entry, and then you bring it to the bibliography. So we are going to take an example. Let's say we want to use novel ensemble methods to do diabetes prediction. So let's say this is the topic. Let me open a new file. Sorry. Okay, good. Now let me open a new file. And let's search for a novel ensemble learning approach for diabetes prediction. Oh, sorry, I wasn't coming here. Let's go to Google Scholar. So Scholar. And then we put it in. Now I want to search for this. So let's say I have it this way. A novel ensemble learning paradigm for medical diagnosis. Now, when you have it this way, and it's a paper you are looking for, what you do is that you go to site. So you see this site. All right. Now, when you go to site, you have all the formats there, the APA, like the Chicago, Harvard, but we are not interested in them. We are interested in the BibTeX. The BibTeX. So you come to BibTeX, you click on BibTeX, and now the BibTeX takes you here. Now you see that over here you have the citation key, you have the title, you have the authors, the journal, and everything. So you copy whatever you have here, and then you bring it into your Bib file. Okay, I think our Bib file is here. So this is our Bib file. So you come and then you paste it here. So we see that it has the same format as the others. So the citation key is already defined. The title is there. The authors are there. The journal is there. The volume, the pages, etc. And this is an article. If it is a book, if it is a conference paper, if it is a thesis, whatever it is, it would indicate that it is an in proceedings conference paper, etc. All right. So please pay attention to it all the time, all the time. If you think you won't get it on Google Scholar, you can get it on PubMed, you would have to check on PubMed, is there a way I could generate the BibTeX file? Is it possible? If it's possible, you can go through it. Something you can ask questions, go through it, and then see how you can generate the Bib file. If you can't get the BibTeX entry on PubMed or any of these platforms, you can now consider typing it one after the other and then define your key. Okay, so quickly, I pick another topic. Let's say I'm doing prediction of diabetes. I know all of us can go on Google Scholar, so we can do that. And predicting of diabetes diseases in ensemble in machine learning. Now we go to site, and then we go to BibTeX. Then we have our BibTeX entry. Then we copy, cancel. We copy this from here, come back and look for our .bib file and then paste it. As simple as that. Okay. Now, when we are done creating our bib file, that is the first step. So you keep putting it, but it is not advisable that you keep compiling them without referencing, bringing in your in-test references. Your in-test references is very important. So all the things I kept stressing on, the numbers, the author year, the blah, 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 they are the in-test references in the test. So sometimes what I personally do is that when I'm working on it, I usually like to, when I put in any reference, I want to do the in-test reference before I even continue. So for you to do your in-test references, you would have to decide on the appearance of the citation. Do you want the citations to appear as numbers in your text? Do you want it to come as author and year? Do you want it to come as a statement like Zook et al. 2024 date ABCD? So depending on how you want it to appear, you decide on the format. So the very common reference packages that we have is the NatBib. Usually the NatBib is used with the BibTeX, and we have the BibLaTeX. Now, these two packages control the inter-citation format and the reference list style. So let's look at them. The first thing, so if I still use the BibTeX, so I mostly use the NatBib. Now you specify the NatBib in there. So depending on the style you want it to show, if you want numbers, you can use the use package, a square brackets, numbers, the NatBib. When you do it this way, then every point, everywhere you cite this thing is going to show as a number, as a number. But then if you don't want the NatBib, if you don't want the NatBib and then you want an author year, you can use the function, the command rand in the square bracket, and it will give you the name of the author and the year. All right. So we use the BibTeX. It's widely used. It's simple and it's stable. So for the in-test references for the NatBib, we can use cite, cite P, cite T. Cite T simply means textual citation. Like you would want to say Zook et al. Contributed to this work. So you don't want everything Zook et al. To be in the bracket because you are making a statement with Zook and you are saying that so in 2025, Zook did ABCD. So you usually would want Zook to come out and then you do that. If you want to do that textual citation, you use cite T. Sometimes you want to do a parenthesis citation where you have said your entire statement. Bread is cooked when it's brown, but it was said by Zook et al. 2021. So that you want to put the entire citation into a bracket. There you use cite P for the NatBib. So let me add this, that this cite T and cite P, you go to your document exactly where you want the citation to appear. That is where you put the cite P or the cite T, and then you go ahead with your, and whatever is here, the Smith 2022 example over here is referring to the citation key. So this is the citation key. This is the citation key. So all the time, if you do your cite T or your cite P, you come and you copy your citation key, then you go and replace it there. Then you're able to generate the exact reference that is of interest to you. When you're using a BibLaTeX, it's a bit more, and usually you would have to insert your reference file. It's one thing I've not mentioned here. So let me just say it. When you are done with everything, you insert, so usually when you call the package NatBib, you go and insert your bibliography / your bibliography slash bibliography into brackets, the reference. So the name of the file you have created. If it's reference.bib, you put it there. If it's my reference.bib, you put it there. However you have named it, you put it there. Then we have the BibLaTeX. I said the BibLaTeX is a bit more current. So in there, when you specify your package, the package is the BibLaTeX, but over here you would have to specify the style, whether you want alter year, whether you want numbers. You put all of that in the square bracket. Then you add your bibliography resource. In the NatBib, it's just \bibliography and you put it in. But here in the BibLaTeX is the bibliography resource and you work with it. It's modern, it's recommended for new projects. So these are the different styles that we have. So we see that in there, the square bracket, we define the style, alter year. We have different styles. So you can do alter year to get it this way, Smith/22. If you want it to be numbers, instead of numbers, you do numeric. And then if you want the style to be APA-like or Harvard or any of them, you specify it here. That is why we say the BibLaTeX is more current. It's more flexible. It incorporates some of these modern stuff in it because for some of them, the old ones, the NatBib, some of them you are not able to specify whether you want the APA. Like, I may be wrong, but it's sometimes difficult to go and look for the Harvard format style and all that. But over here, you can specify those formats that you want. So just like the NatBib, in the BibLaTeX, you can also cite with cite, that is the basic citation. Once you do cite, it will do the cite for you. If you want the parenthesis citation, like I said, the cite P in the NatBib, over here is the parent cite, and then the key would come. Then if you want to cite the author in the text, like I showed you in the previous example, over here is called the test cite. Okay. So in here, if you want the parenthesis citation, it's slash parenthesis cite, parent cite, then you continue with the key. If it was over there, it was cite T. In here, it's going to be test cite, and then you're able to work along with it. Okay, so this is an assignment for you. Because we are almost behind time and Prof has to wrap up, I'm going to give it to you as your assignment. Please try your hands on them. If you have a tech, if you have a full document you are working on, you have challenges, you can always reach out. Now, this is the last thing I want to mention. I know most of you use most of these common tools to manage your references. Some of you use Mendeley, some of you use Zotero, Jabref. I have been using Jabref for a long time, but just recently I hooked on to Zotero and I'm so much in love with Zotero. Now, these ones help you to put all your materials together and they help you to create your bib files from them. So I'm going to give us a very brief scenario, very, very short. Now my new found friend is Zotero. So let me say Zotero. I open my Zotero and so you can have, that's one thing I love about the Zotero. You can create your multiple projects. You don't have to lump all your papers together like the other softwares. Now in Zotero, you can group your different projects that you are doing. So one of the projects I'm currently working on is a diabetes project, and I'm also doing some rivulet reviews. Now, when you have all your papers arranged here, and you have read these papers and you want to reference all of them, so that it can be thousand papers that you have read, and you want to reference all of them in the paper that you have. You don't have to go to Google Scholar and be doing them one after the other. All that you need is to bring the paper on Zotero. Now, what you do is that on Zotero, you can go to File. Please take note. You can go to File. Then you go to Export Library. Now, when you come to export library, you see that you have BibTeX, BibLaTeX, and we have JSON format, all that. But right now, we want the BibTeX. Then you go to OK. Then you save it. So you can change the name to, let's say, my ref, whatever name that my reference is on my ref. Then let me keep it on my desktop. So let's go save. Now, when I save this thing on my desktop, I can come back and come and look for my ref. Good, it's here. When you open it, you see it gives you everything, including the abstract. For most of the papers that we write, we don't care about the abstract in there. So you can go ahead. That is the extra job that you can find yourself doing by deleting the abstract components out of the work. So once you do that, you realize that you have the full bib citation for the work. Then you copy this into the folder you are working in, whether you are working on Overleaf or you have a local file you are working from, you just copy them and put them there. So you just do your few finishing tactics and then you are good to go. You don't have to go to Google Scholar and do them one after the other. So whether you are using Mendeley or Zotero or JabRef or any of them, even JabRef, it's easier. You can do your citations directly from JabRef. It's very easy. So you can do all of that from there. If you're using Mendeley, just figure it out how you could generate your bib file from there. I just showed you how to generate your bib file from Zotero.